Hello, we are Team 61, and this is our pitch for Team 62. So, Team 62 requests were for an uncashable car. So, they wanted a car that, when approached by a person, would drive away. The car needed to move fast enough to evade the user at a moderate pace. They wanted to be light and relatively small, and they wanted, if you're able to catch the car, that it should stop. So, questions we asked: does it need to move in only one direction? And they said it only needed to move in one direction. Does it have any style constraints? They said it should be colorful and cool. And we also asked, does it need to turn? And they said no. So this helped us simplify our design and guided us through the design process. So our design process, first we defined the problem by listening to the requests. Then we acquired pertinent data by asking them questions. Then we identified criteria and constraints by creating specifications. Then we developed alternative solutions through brainstorming. Then we selected a solution through the decision matrix, and then we communicated our results through the final prototype demonstration. So here are specifications. So we put the customer needs in, the technical needs, and then we turn those into technical requirements and target values. So we changed the will drive away to distance and changed it to within 20 centimeters for technical requirement and within 45 for target. For moving fast enough, we changed that to motor power percent. And for technical, that was between 10 and 60%. And for target value, that was between 10 and 50%. And for being light and relatively small, we changed that to weight in ounces. And technical requirement is less than 12. Target is less than 8. And for being able to stop, we just said it should use the touch sensor for that.
So now we move on to the system diagram, which includes how the robot actually works. So we had two inputs for like energy and the hand motion, which was detected by the ultrasonic sensor. So all this input was fed to the distance detection system, which was basically programmed to detect the distance and reflect back to the ultrasonic sensor, which further went to the drive system, which allowed the motors to operate at a certain speed, which led to movement. Next, here comes a flowchart, which basically explains how the code of the robot worked. So at first, we get the ultrasonic input from the movements of the hand. And then it leads to three main desired questions. If the reading of the ultrasonic is above 50, then it would move at a normal speed. If the movement is like less than 50 and greater than 20, that would make it that this is done so it would get the hand input or the movement input from any motion detection from the ultrasonic sensor and would allow the motors to move at full speed. And if the reading is less than 20, it would cease all motors and it would eventually stop.
So we did have a few design alternatives when creating this robot. Our primary one being the number of wheels that we would put on the robot, either 3 or 2, or we ended up with 4, which will be discussed in the decision matrix on the next slide. We also thought about putting in 2 motors. We realized that this was kind of a clunkier and more difficult design to work with, so we decided to stick with 1 motor that would drive the wheels and have the wheels trail behind on the other end of the robot. We also had to decide how to place the pie and how to balance the weight with the robot, and also how to manage the wires from the pie to the different systems. So here is our decision matrix for the number of wheels that we wanted to put on our robot. So we weighed a few factors, how compact it was, how light it was, how fast it was, and how cool it looked. And we placed the most importance on how fast it was because that was ultimately the main function of the prompt that we were given. And so for our 3-wheel design, it was the least scoring of the 3 designs, mainly because it didn't go as fast, which was obviously the most weighted qualification. The 2-wheel design went a little bit faster, but it still was not as successful as the 4-wheel design, which ended up being our final design.
So here's our final prototype and video of it working. As you can see, as mentioned previously, we ended up going with the 4-wheel design. Our robot also has 1 motor, and it uses 2-wheel drive. It features 1 ultrasonic sensor and a touch sensor with the Raspberry Pi also mounted in between all 4 wheels. And as you can see in this video, the robot moves once the hand has reached a certain proximity of it, which was exactly the specifications that we were given. So overall, our robot did meet the specifications given by Team 62. So just to recap, they said that they needed a car that when approached by a person would drive away. And as seen in the previous slide, we were able to achieve this since our car did drive away from the user. Additionally, they said that the car needed to move fast enough to evade the user at a moderate to slow pace, which once again, as you can see in the video, the car increases its speed once the hand gets closer to the car, so it essentially runs away faster as the hand moves closer. Additionally, they requested that the car be light and relatively small, and we did our best to make a compact design that is not bulky or heavy, and it was as light as we possibly could make it. And finally, the final specification was that if the user was able to reach the car, they should be able to stop it. And this was achieved because we programmed the robot such that when the user got within 20 centimeters of the car, it stopped.